Okay, thanks, Sankalp. So what I wanted to do today is talk about some of the innovative AI applications we are developing at Amazon, and also some of the big open AI challenges out there. But first, I wanted to just show you a video of that gives a good overview of how we are using AI for some advanced applications in at Amazon.
I think natural language understanding, I think machine learning in general, artificial intelligence, probably hard to overstate how big of an impact it's going to have on society over the next 20 years.
The vehicle is completely autonomous. It lands by itself, it navigates by itself. It can fly more than 50 miles an hour. It has a 20-mile range.
We're really just beginning in robotics. It is the birth of robotics right now. We use our machines at Amazon so that we can have a more efficient fulfillment process. Ultimately, it's about humans and machines collaborating together in order to achieve a meaningful task.
Alexa, add anniversary to my calendar.
Alexa, accept the call.
Hey, Mom.
Alexa, play my relaxing playlist.
Alexa, turn off the lights.
Okay.
So with Amazon AI, we're bringing the power of deep learning and advanced machine learning to all developers so that they can bake intelligence inside the heart of every application and inside the heart of every business.
Recognition allows you to pass an image to us, and we will detect objects in an image. We'll be able to tell you that there's a person in this image, or it's a woman in this image, or it's a car.
With A9, we're completely reimagining what it means to search. From landmarks to books, visual search enriches the world around you with contextual information powered by artificial intelligence.
Today, we don't have any if conversation. Every conversation is a when and how conversation. This is a world that I want to live in.
Okay. Yeah, so, many of the applications shown in the video are all being powered by artificial intelligence and machine learning. What I thought is I do in the remainder of my talk is describe some of the applications we are building within my team here in Bangalore, and also talk about some of the big open AI challenges. So we all know that customer reviews on Amazon contain a wealth of information about products, and they capture user feedback and sentiment about different product aspects, and they give insights into product aspects that customers care about. So here on the screen is a review, and it has mentions of a number of different product aspects like look, handle, price, space, and so on. And this is for a trolley in a luggage category. And, so one of the things here, what I've done on the slide is I've circled some of the snippets with positive sentiment. For example, a sturdy handle, that's circled in green, and then there are some snippets that contain negative sentiments, and those have been circled with red. And one can aggregate the sentiment information across all the reviews to generate something like this. And this has fine-grained ratings for all the product aspects, and it's completely generated out of the text that's contained in reviews. So you can see that there is a negative sentiment for lock, but there are positive sentiment for wheel and some other aspects of the product. And this is very useful for manufacturers. They can come up with new product designs, for example, that improve customer experience. This is also useful for customers as they go about making purchase decisions. And of course, manually sifting through thousands of reviews to unearth this data, to get this user sentiment data out of reviews is very tedious and time consuming. And this is where ML, natural language understanding, and sentiment analysis comes in. We're able to mine all the reviews to get not only the product aspects, but also the sentiment for each of these aspects from reviews. We're also working on question answering. Many of our product pages have a lot of text in them, and it becomes difficult for users to find information that's embedded in product descriptions, and customer reviews, and community QA, and so on. And what we've done is, a lot of these product questions are about product features. For example, what is the battery life? How much is the camera megapixels, and so on. And we have interfaces where people can ask questions like, how heavy is this product? And it'll come back with, the answer here is 8.6 ounces, or people can even ask questions that are very subjective answers. For example, is this camera expensive? And we're able to extract the answer from one of the snippets in a customer review, which here says, for the price, this camera is good value for money for an amateur photographer, right? So again, using all the content that we have on products on our detail pages, and use those to answer questions that customers may have. And all this is natural language. We're also working on a conversational shopping engine that interacts with users very similar to how users may interact with a shopkeeper, for example. It guides users towards the product that they are looking to buy by narrowing down or refining the requirements in each step of the conversation. So here you have a user who has expressed an intent to buy a phone. Our shopping engine narrows down the requirements to something in the price range of 5,000 to 8,000 rupees, and from with the brand Xiaomi, and it also suggests some deals on Xiaomi that are available on Amazon. Robotics is again a big area for us. Our fulfillment centers are huge, the size of multiple football fields. If you're manually transporting products from shelves where they're stored all the way down to the packaging area, it could require humans to cover very long distances. So we have these Kiva robots, and these are these orange boxes here, and they automatically transport packages from shelves to the packaging area. We're also building robots that can pick products from shelves and put them in these yellow containers here that then get transported by these robots. Now, picking is very easy for humans to do. Of course, it's difficult for children to do, and they have to learn how to pick, but it's extremely difficult to get robots to do it. So it's still work in progress, getting robots to do this in a very efficient way. Our drones use computer vision techniques to recognize objects and patterns, and this is required to safely deliver packages to customers' homes. You don't want to hurt children or pets as your drone lands in somebody's backyard to deliver a product. So you need computer vision there to make sure that the landing space is clear. We're also using computer vision techniques in the grading of the quality of fruits and vegetables. The input to our assaying and grading system are images of agricultural produce, like the ones shown here, and the output is the grade that's predicted by our ML systems for the produce. So it could be poor, as in the case of the tomatoes that are sort of rotting on the left, and then excellent on the right. Now, some of the big AI challenges out there there's all this excitement about AI, and of course AI has delivered results and has made a difference to businesses in many different domains. But there are still limitations in terms of what AI can and cannot achieve. So for example, consider the problem of automatically generating a Wikipedia page on any topic. This is an extremely difficult problem. It requires great content summarization technology that we don't have at the moment. Of course, if you had great content summarization technology, you could do a search on Google, get the top 100 most relevant pages on the topic, and then summarize the content in them to generate a Wikipedia page. But again, I think content generation and content summarization is still an open challenge out there. There's a lot of research being done on generating captions automatically for images. But a huge challenge, and researchers have met with some success there, but a huge challenge still remains in terms of generating descriptions for video. Or if you went one step further, generating an expert review for a movie, for example. That's something that still your most sophisticated ML systems can do. And I'll just conclude with this. Clearly, you have sensors increasingly on personal fitness devices in people's homes that are generating massive streams of measurement data. And, how do you analyze these data streams in real time, for example, to detect if somebody is having a heart attack or a home is on fire? And this requires a lot of, online algorithms in terms of detecting anomalies and so on. So I'll stop with that and hand it over.
Thanks,
to
Rajiv.
Andrew.
Andrew's going to take us through microservices next.
Hey, everybody. So airline flight search is one of those famously hard problems in computer science, and it's only getting more difficult today. So about 5 years ago, there were 5 billion combinations to search through if you were looking for a flight from New York to London. Today, that number has grown more than 10 times. So the number today is about 63 billion options, right? And that trend shows no sign of slowing down. Sabre systems actually power those flight searches pretty much wherever you look. So if you're on a mobile app, if you are looking on a third-party travel website, if you're looking on an airline's own site, or even if you're talking to a travel agent, Sabre systems are powering that. And in fact, at peak times, we're generating about 1 million itineraries per second. And each one of them uses large amounts of compute. They are looking at large in-memory data sets, all to do the pricing and availability for those combinations, right? So about 10 years ago, because of the scale of that and our need to keep on innovating there, we turned to using microservices. And in fact, I looked it up. We've been using microservices for slightly longer than the term microservices even existed. So let me give you 3 things that we've learned along the way. The first one is that simplicity really wins when you are talking about microservices at that 10x scale. And by simplicity, I don't mean taking features away from your product. Specifically, what I'm talking about is reducing complexity in all parts of the system. So if you think about the communication between the microservices, limiting the ways that you do that, if you think about even the technology stack that you're using, kind of trying to limit the variations that you have there, with the idea being that any one of those choices individually may be optimal, but when you put them all together, that complexity is what really kills your use of microservices, and it prevents people in some cases from being able to move from one to another. It makes it hard to manage in production. So really getting a handle on that complexity and simplifying in every place that you possibly can, every time that you think about a new architectural change is really important. The second one is to focus on the service part, not so much the micro. I think that people, when they start using microservices, have a tendency to look at their code and chop it up into as small pieces as possible and get fixated on this, like, one purpose for an individual service. But really, Sabre services have a reason for existing, every one of them, right? So, one of them might be very compute intensive but stateless. One of them might use large amounts of RAM. One of them might be stateful because it's got all of this intermediate state as you're doing a search. And one of them might even talk to a database. All of them individually have a reason for existing, right, and a different resource profile. And so, it's a different service. So I think a good test for, the simplicity and the service aspect is if you ask a person who's working on an individual piece of the system to draw a diagram of the entire system from start to finish. A request comes in, passes through all of the pieces, response goes out, label all of the boxes and all of the lines, right? If they can't do that, or if they start on one whiteboard and then they move to another one and basically like go around the entire room drawing your services, then you probably have something that's too complex. If what they're drawing is a lot of things that look like, more like ladders than fans, right? Then it's complicated in a different way that there's, I would say more attention paid maybe on the micro aspect than the service, because it might be possible to collapse some of those ladders if they don't really have a reason for being separate. And likewise, if you have a lot of components that, their functionality overlaps, like they're all talking to the same database, maybe it might make sense to collapse those as well. So it's really, again, just trying to simplify as much as possible and keep things from being too complicated for developers to keep in their heads, too complicated to manage in production, and too complicated to keep scaling, right? And the last lesson is to really get comfortable with the in-between states of your system, because that's where you're going to be spending the vast majority of your time once you get to scale. So I like to tell teams that they should be able to take a lunch break during a release and not even worry about the system, right? Because ideally you would get to the point that you would have automation and you would have monitoring of all your critical metrics, looking at error rates, latency on the system, but you're basically decoupling all of the services for releases, and you're doing rolling upgrades. So one server at a time gets the new release, right? And it's just not a big deal as it's happening. But I think it's important to focus on getting there rather than, kind of like half steps, like doing blue-green deployments, if what your goal is to actually support that kind of 10x scale. Because eventually you're going to need to get to rolling upgrades, right? And there's a fundamental difference in the way that you design your software and the way that you deploy it to really operate in that way. So for instance, if you think about services as they're being upgraded, you have to have backwards and forwards compatibility between each one of them as they're talking to each other. If your service is connecting to a database or using a cache or something like that, you have to be prepared that version 2 can read a record, update it, and then version 1 reads the same thing, operates on it, and vice versa, right? These are kind of, fundamental shifts in the way that you're thinking about developing your individual components. And most importantly, it's a big shift in the way you test them, because you have to try out all of those combinations. But I think it is important to get to that point as quickly as possible if what you're trying to do is use microservices at scale and use it in a way that people can be independently working on all different areas of the system at the same time. All right, so those are kind of our lessons so far. And then I have 2 predictions for the near future. The first one is that shared services will really start to enable more innovation happening throughout a company, right? I think that innovation isn't just purely something that happens in a research organization or in a labs organization. It's really something that also has to happen throughout a company, right? Every product development group has to be able to innovate to really do it at scale. And shared services, I think, will be a way to do that, right? If you think about, if you have a base of shared services for all sorts of different things that your company does, and it's possible for an individual development team to plug those together in different ways, add a little bit of their own app code, they can use that for supporting hackathons, for doing rapid prototyping, basically getting innovation at scale all throughout the company. So I think it's only a matter of time before companies start to realize that and actually have dedicated teams whose purpose is to work on those shared services to enable other innovation happening company-wide. The second one is that standardization will be the big thing that really increases adoption and also adds more value to microservices. Honestly, I think the lack of standardization and the amount of choice in the tools that are used, the frameworks, even just the design choices as you're building microservices is the biggest thing that's hurting adoption today. So, you know, standardizing on more full-featured frameworks like gRPC over REST or, you know, Kubernetes and Istio over homegrown systems is really the way that developers will be able to focus more on the value add and not spend as much time thinking about the technology stack. So those are my predictions. That's our microservice journey so far for shopping, and you know, we've since started using microservices in a whole bunch of other areas throughout the company, and really that's the way that we've been able to achieve 10x. So good luck in your own microservice journey, and thanks.
Thanks, Andrew. All right, Ram, over for you to bring us home.
Thank you.
Thanks.
As you can tell from the dress code, Sankalp made us all wear stuff. I'm the infrastructure guy, right? So, okay. Just go to the next slide if you can. All right, there we go. So what's the implication? I think what Rajiv talked about and what Andrew talked about is the fact that, you know, digitization is exploding, right? I mean, you know, we have to be living in a cave. We didn't touch our phones 2,000 times a day, you know, consuming all the stuff that Rajiv and Andrew talked about. You know, all of this needs to run somewhere. So digitization is a given, right? $7 trillion between 2019 and 22, 23, whatever number you can choose. $7 trillion. You know, 60% of global GDP is going to be digitized potentially by 2025. What does that mean? 500 million new applications are going to be built in about 5 years, which, you know, just to frame that equals about 40 years of application development to date. And all the things that, you know, they talked about is what's exploding this over time, right? And probably 40% of cloud deployments are going to include edge of some sort. So it's not just the enterprise. It's the enterprise is proliferating, right? It's proliferating all the way from the core, you know, their primary data centers to public cloud, et cetera, et cetera. We'll talk about that. That's really what I'm going to focus on. You know, if you think about the superpowers of technology, right? I think, you know, yesterday Deep talked about it as well. You know, there's cloud, on which everything is now actually, you know, running. There's mobile devices, which is about infinite reach. Cloud is about infinite scale. Mobile devices are about infinite reach. AI and ML is powering the core of all of this. And edge and IoT are coming in from which data is getting acquired and sense is being made of it through all of these other technologies that are getting built. So on the cloud front, I'm just going to focus on that a little bit. For the longest time, the cloud discussion was either, you know, on-prem or public cloud, edge cloud. All of these were being discussed as independent entities. But what is really happening is, you know, I think Andrew alluded to this, the fact that standardization is becoming more and more important. It's not about a private cloud strategy versus a public cloud strategy. It is not about a particular public cloud strategy versus, you know, whatever they're doing on-prem. That really what's happening in enterprises of large sizes as well as medium sizes and smaller as they start to adopt technology is the fact that all of this is becoming a continuum. The fact that you need to have a hybrid cloud. But what I mean by hybrid cloud is you need a public cloud. You also need a private cloud. If you are a regulated enterprise, you're not going to start putting a lot of your customer-specific data out there, right? And we were talking about this just before the panel. all of us, we all worry about privacy, but the reality is there is information about individuals and enterprises all over the place. And, as much as everybody tries to limit this, it is a strategy that needs to be built in. But at the same time, there's also the public cloud. It allows you to actually expand much more easily about various things that you want to do. So it really, for an enterprise, this becomes a choice. And you cannot, for an enterprise, this cannot be two distinct choices. They need to be able to future-proof themselves. They need to have speed and agility for deployment because their customers are demanding it. All of us are demanding it as consumers of these enterprises. Compliance is a massive requirement. There's very few industries out there which are not compliant, which doesn't worry about SOX compliance and various other compliances. Time, cost, space savings. I mean, people, talk about, evacuation of data centers are all discussions that every enterprise is having. How do you do this at a cost point that's effective, at the same time be able to invest into all the things that their customers are demanding? And of course, scalable, right? You need a scalable strategy. It's infinite scale. The fact that every one of us are massively consuming, applications and data requires scale on the back end that needs to be completely transparent and invisible to the fact that the application is starting to scale. If you look at the worldwide market, it's about a $500 billion market if you think about the cloud market, right? Individually, if I break it up by public cloud, private cloud, edge cloud, telco cloud, cloud is all over the place. But what makes this really interesting, and the opportunity is probably even larger than the $500 billion that seems to be out there, is the combinatorial aspect of this. The fact that every enterprise has got every one of these things playing out in their enterprise. You cannot but have this, right? So the opportunity map becomes really, really large. And for, companies of all sizes, Sankalp and I work for the deep infrastructure companies. This is a massive opportunity for us, but it's not just for us. For many of you who are building B2B startups, right? Let me take it to the other end of the spectrum. What this opens up is opportunities in terms of applications, the next layer below that, management of these applications, all kinds of opportunities. So, standardization is a very key aspect that we talked about. Everybody worries about these 5 big areas. One is how do you build these applications? Cloud native is a big piece. If you're a traditional application shop, now you need to figure out how you're going to actually containerize it and deploy it at scale. How are you going to run these applications? You need a cloud and the infrastructure underneath to run this. How are you going to manage it? 500 million applications getting built. That doesn't mean the old applications are going away. You're going to need a hybrid application strategy. That's going to require you to manage every layer of your enterprise from all the way from the customer-facing piece all the way down to the last mile. Connecting all of this. You cannot deploy a network architecture every other day. You need to future-proof yourself as an enterprise. When you talk about, how are you going to create the connect in order to run all of these applications, manage the data, all the other things that we talked about, and last but not least, protect. This is not an afterthought. The reason protect is at the end is not because it's the least important. In fact, I would put it right in the beginning. Ability to protect at scale is a very different problem than band-aiding with a lot of the security applications that most enterprises work today. I know for our IT department uses about 200 plus applications just on the security space. It's unscalable problem, right? You cannot continue to do it the way it's been done. Huge opportunity here for startups to start reframing about every one of these areas. And then just coming back, right? The future is about managed clouds. When I talk about the cloud infrastructure, it has to be managed, but not just managed the way you do it manually, the way it's been managed in the past. You need self-running operations. You need automated operations at a cost point and a scalability that is unprecedented, right? You need a governance model that goes with this. You need to be able to, last but not least, do service integration, right? All the things that Andrew talked about. And do this at scale, automated. Now here, I wish I was 20 years younger and building a startup. I'm not, but, that thought crosses my mind. But for many of you who are entrepreneurs in this room or potential entrepreneurs, I think the world is going to look much rosier as you look out over the next 5 to 10 years, irrespective of which piece of the stack that you're operating in. Thank you.
Thanks, Ram. So let me start the Q&A off with a very interesting story I read on New York Times 2 days ago. An article that came out that talked about a company called SIFT, S-I-F-T. And that company apparently makes Cambridge Analytica look like a puppy. And what SIFT does actually, and this was amazing, was SIFT has a proprietary scoring algorithm that looks at 16,000 factors for an individual. and it decides whether or not you can be trusted. Until date, they were not sharing that information with you. The New York Times journalist wrote to SIFT, got his file, and received a mere 400 pages about his activities. Everything from his Airbnb messages to hosts to Yelp delivery orders to a log of everything he'd opened up. 400 pages. So the question I have to the panel, beyond the technology and the amplification of it, it seems we're moving from a technology paradigm to a moral paradigm. Right. What are the boundaries we should define for some of this? And when will we even be aware of some of these paradoxes out there? So Rajiv, you want to kick it off?
Sure. I think most of the companies out there that do, collect user data. I mean, at Amazon, we do know what customers purchase and so on. And our intention usually is to leverage that data to make the experience better for customers. So clearly, when you have a catalog with billions of products, it can be a challenge, a huge challenge for people to find what they are looking for. So if you, to the extent that you can personalize results or recommendations, for example, to what to suit customers' preferences and tastes, it's a much better experience for your customers. So I think it's fine to leverage data that you may have on users or knowledge that you may know about their preferences and tastes to make the experience better, to show them what's relevant, to show them content or products that they may be looking for, and to make their job easier. And of course, I think there's lots you can do even without getting individual personal data. For example, on our websites, we do, when you're browsing, looking at a certain product, we also show you information about other products that were frequently co-purchased with this product. And that really isn't looking at your individual data, but it's looking at aggregate data of, what were pairs of products that were purchased together. And of course, it's very useful for a lot of our users to know what are the other products that are relevant that people purchase along with this product. So it's really about making people more productive, improving the experience for them, and helping them find and complete tasks that they're out to achieve on our website. And I'm sure that's what happens with other websites that are personalizing recommendations and results for users.
Thanks, Rajiv. Andrew?
I think that there's kind of a user trust issue there, honestly. If you think about going to Amazon, you would expect that Amazon remembers your past history of what you purchased. You can see your order history right there. If you're providing a benefit because of that, I think that that's totally reasonable. If you go to some website and it's sharing your information with 100 places that you've never heard of, there's an imbalance there that people just don't understand what's happening, right? And they don't have visibility into it. I think that that's the real issue as far as things like that goes, right? I mean, people like personalization. I think personalization as a trend is something that's only going to increase over time, right? You can even imagine, areas all over the place that right now are just returning static results or being used in inflexible ways. Personalization is a benefit, and that requires data. But I think that, if you show the benefit of that and people have an understanding of how their information is being used, that's reasonable. The issue, I think, comes in when there's an imbalance there and they don't have visibility and they don't have understanding and they don't necessarily have a choice.
Thank you. Ram, your take?
Well, I think, this is where regulatory comes in, regulatory and compliance, because to a large extent, if you look at something like GDPR, and which is being widely adopted now across countries and not just in Europe, it's about moving the ownership of data back to the individual. right? I mean, that's really what it is about. The two big discussions that are happening around data privacy and ownership and data domain, whether you should keep the data where it belongs, right? So whether you keep it within. So having said that, I think a lot of it is also the responsibility of the organization which is collecting and managing this data to use it in the right way for the right reasons with the opt-in of the users who actually own the data. So if somebody, if I allow, let's say, let me point to either Amazon or Sabre and tell them, look, I'm giving you the permission to use my history to give me a better experience. But I trust the fact that they have the right compliance and governance in place, that they use it for the right reasons and it's not leaking out. But we have seen this. I mean, where there is a fair amount, some of the large companies, who've been in the news lately, there have been situations where, for example, passwords were stored in clear text, right? I mean, which is a complete no-no in this day and age. I mean, this was happening in the early days of the internet, I understand. But this has ways of, allowing things to leak. So I think government is stepping in. There is a lot of policy discussions that's coming in. If companies don't fix it on their own, they're going to be forced to do this without any control over themselves. And that's where it's leading to.
Thanks, Ram. So interestingly, SIFT is one of 4 companies in the States that's providing such information. So if you guys are curious, check it out. Now, with that, let's open it up to all of you for any questions you'd have for our panel. Please feel free to ask them anything that's on your mind. You guys did such a good job.
We have a stunned audience here.
You have a stunned audience. Anybody would like to ask them anything, please.
There's Mike behind you.
My question is to Andrew. While implementing microservices, I read that there's a couple of containers which has some kind of vulnerabilities. So how to judge a right container?
Containers which have what?
Docker and Rocket.
Oh, okay. Yeah. I mean, I think that in general, the container itself isn't the most interesting part. I think basically as long as it works with your existing ecosystem and you get some of the basics like metrics that are important to you and perhaps routing or some of the newer service mesh sort of thing, then in general I don't think that it matters too much. I think the thing that's really important is to standardize on one, move on from there, right? And keep the focus on the services themselves and adding value.
So till my knowledge, what I was thinking, like we can implement one layer above all of this container to measure those security aspects. And then only we'll pass the request to the containers. Is this a good approach or right approach?
Yeah, so that is basically the service mesh approach, right? You have a very simple service that's just doing its core functionality, and the only thing that it talks to is what they call a sidecar, basically. And that sidecar is what it handles security, it handles message routing, transformation, all of that sort of thing. I think that is a nice approach in general because it allows you to change the service more easily without worrying about all of the other libraries and ecosystem and everything that goes along with it. Yeah.
Thank you.
Mm-hmm.
Other questions, guys?
Thanks all of you for a great talk. And I'm with VMware, and I have a question which is kind of technical, but not technical as well. So any of you can pick the answer, or all of you. So there's this book by Barry Schwartz called The Paradox of Choice, right? So, and as an architect, as a product architect, the problem I'm faced with is that if you look at each of these areas, AI, cloud, microservices, there's so much around it, so much choice around it, that to put elements of it together into whatever it is that we're building, right, to solve a customer problem, how, or is there a general approach to narrow down the choices, especially the point about simplicity, right? The more moving parts, the harder it is to build and run the system. So what's a good way to approach some of this? How do you sift out how much of this is hype versus how much of it is something that will be long lasting? And you can trust it enough to put it into a product. So how to navigate the paradox of choice in these areas?
Yeah, I mean, at least in the ML domain, you always resolve choice related questions with data. So, typically, if you look at ML workflows and pipelines, they'll try out, there are, first of all, many different algorithms you can use for solving a problem. You have different types of modeling algorithms out there. You have linear models, you have gradient boosted trees, you have random forests, you have deep neural networks, and each of these algorithms has, some 20 different knobs and parameters that you've got to set to try and, and they could give you different results. So typically in machine learning, you have holdout sets, which are data with ground truth information. And you try out different choices, you try out different parameter settings, and you pick the choice, the algorithm, and the parameter settings that give you the best results on your holdout set. And of course, your algorithm has to meet the constraints in terms of memory size, latency, and there would be other constraints like that. So you've got to then select the algorithm that meets all your constraints that you may have from an engineering perspective and gives you the best results on your holdout set. So it's completely a data-driven approach, and at least that's what works in ML. I'm guessing that should carry over to other domains as well. It has to be based on some data that and as objective as you can get about what you're trying to optimize is going to help you make a sharper choice.
Great, guys. So all three of our panelists are available for follow-on discussions. They're here through the day. We're out of time, so please give a round of applause to our three panelists for sharing their insights.